All right, so the next titration experiment we are going to look at is back titration. Now, I'm just going to run over the general overview of back titration. Now, what is back titration? According to what we have on the screen here, I'm just going to read through what we have here and then I'm going to make an explanation for it. Now, back titration involves addition of SS. Please take note of this because you may be asked, what is back titration? I remember we are answering our time in the PCH 221 main exam. Back titration involves the addition of excess of a volumetric reagent, e.g., sodium hydroxide, with a pipette of required volume to a weighed amount of sample. The estimation of the excess reagent, which does not react, is then carried out. This method is useful for the assay of the following substances. Now, what are the substances that we use back titration for? The substances which require the use of heat in determination, they use back titration. The heat may cause the composition and loss of reactant and product. Hence, you use that back titration. Also, volatile substances which may vaporize during assay, e.g., methanol and ethanol, and insoluble substances like calcium carbonate and lead sulfate, and substances for which a quantitative reaction proceeds rapidly only in the presence of what? An excess reagent. Now, this one is the one you should take note of very well because everything we are going to do under back titration falls under this one here. So substances for which a quantitative reaction proceeds rapidly only in the presence of an excess reagent. The one we are going to use is the salicylic acid, which is acetylsalicylic acid. The reaction only proceeds in the presence of what? An excess reagent. Is that okay? So that is that. Now let us come back to writing to actually explaining what the back titration is. Now, I'm just going to explain to you what back titration is. It's very easy. Now, the back titration, look at how it is done. You actually have a substance that you want to assay. Are you getting it now? Let's say you have acetylsalicylic acid. Acetylsalicylic acid is called aspirin. And then you have sodium hydroxide. Now, you are going to add acetylsalicylic acid, which is aspirin, to an excess amount of sodium hydroxide. It means sodium hydroxide will be in what? Excess. Now when we talk about excess amount, it means, let's say aspirin need, let's say 1 mole of sodium hydroxide to react, and you add like 3 moles of sodium hydroxide in it. You know the amount of aspirin that is here. Let's say aspirin needed 1 mole, and you add like 3 moles of sodium hydroxide. The sodium hydroxide is what? In excess. Why? Because normally aspirin and sodium hydroxide need 1:2. I'm just trying to tell you the mole ratio. 1:2 mole. Are you getting it now? So it means 1 mole of aspirin, we need how many moles of sodium hydroxide? 2 moles of sodium hydroxide. But now you are having how many moles of sodium hydroxide? 3 moles of sodium hydroxide. Now it means at the end of the reaction, now let's understand something. The molar ratio is 1:2. 1 is for aspirin, 2 is for what? Sodium hydroxide. Mole. But you have 3 moles of sodium hydroxide. It means how many moles of sodium hydroxide is in excess? 1 mole. Are you getting it now? Now that 1 mole of sodium hydroxide that is in excess, you are going to transfer it to another what? Conical flask. Are you getting it? And then you are going to what? Titrate this one. Are you getting it? So at the end of the day, when you titrate this, if you now know the amount that is actually present here, let's say you now know that at the end of the estimation, 1 mole was what was actually present, because you know titration will actually tell you the number of moles that is present and the mass that is present. If you know that it's 1 mole that is in excess, and you know that normally the molar ratio is what? 1:2. Sometimes you may not even know the amount of excess reagent. You may not know that there are 3 moles here. That's what I'm telling you. Sometimes you may not know that there are what? 3 moles here. But after carrying out your titration and you discover that the excess reagent is how many mole? 1. What is the normal molar ratio that they are supposed to react with? 1:2. Are you getting it? It now means that since you have 1:2, it means that the amount of sodium hydroxide that was actually there in excess is how many mole in total? 3 mole. Because you know 1:2, it means 2 moles was supposed to be here. Then plus this 1 mole now, which is the excess, will give us what? 2 mole. Now how about after carrying out the assay and you got 2 mole of this here? That means the excess reagent is how many mole? 4. naturally. Are you getting it now? Now, this may not make sense to you until you now do the practical. Now, the practical for back titration is very easy. Let me just show you how you actually carry out the main practical itself. It's very, very easy. Forget about the nonsense we've been saying since. Now, the only thing you do is, first of all, the reaction is between most times sodium hydroxide and what? HCl. So you have your HCl here, and then you are going to titrate it with what? With sodium hydroxide. Are you getting it? Now, this one here is called blank. The blank one, listen, is the sodium hydroxide that do not contain aspirin. Are you getting it now? The blank is the sodium hydroxide that do not contain what? Aspirin. Is that okay? Now, you are now going to come here again and do the main titration. Now, the main titration will be this one here. You see, use HCl. Then this one here, blank, which is only sodium hydroxide is present here without what? Aspirin. Now, the second practical, you have sodium hydroxide plus what? Aspirin. Are you getting it? Now, one thing you should know is that aspirin is an acid. Are you getting it? So, aspirin reacts with sodium hydroxide. Aspirin will neutralize some of the sodium hydroxide here. Do you get it? So, the total mole of sodium hydroxide here will be what? Small, as compared to the total mole of sodium hydroxide here, which should be large. Why? Because there is no aspirin to actually react with the sodium or to neutralize sodium hydroxide. Aspirin is an acid. Sodium hydroxide is a what? A base. So sodium hydroxide and aspirin are supposed to come together to form what? Salt and water. But for the blank, aspirin is not there. So it means the moles of sodium hydroxide will still remain what? The same. Do you understand? Why, if you come here, the aspirin here has reacted with some mole of the what? Sodium hydroxide. Do you get it? Now, if the mole ratio initially is 1:1, let's assume 1:1, and then let's say you have 10 moles of sodium hydroxide here. If the mole ratio is 1:1, if you have 10 moles of sodium hydroxide here, it means how many moles of HCl will actually react with this? 10 moles of what? HCl will react with this. True or false? Because the mole ratio is what? 1:1. Are you getting it now? Now, but when you now come to that of aspirin, now because aspirin actually react with some of the sodium hydroxide here, the number of moles of sodium hydroxide, do you think it will increase or it will decrease? It will decrease. Do you know why? Because aspirin already react with some of the moles here. So let's say the number of moles of sodium hydroxide is what? 5 mole that is remaining here. Are you getting it now? Now, what volume of HCl, how many moles of HCl do you think will now react with the 5 mole? Since the molar ratio is 1:1, it means 5 mole will what? React. And you know that this 5 mole is directly proportional to the titer value. True or false? True. So the titer value here for the main experiment will be smaller as compared to the titer value for the what? Blank. Is that okay? So it means the blank will have a high titer value as compared to the what? Main experiment. Do you understand? Do you understand? Okay, let's say at the end of the day, the amount of sodium hydroxide here, let me just use this to just give an illustration. Initially, let's say 10 moles of sodium hydroxide actually reacted here. True or false? Now, how many moles of sodium hydroxide reacted here in this particular one? 5 mole. Now, if you subtract 10 moles from 5 mole, how many will be remaining here? 5 moles. True or false? Now, what is that one telling you? That one is telling you that that 5 mole that we now have, which is the 10 mole from blank minus 5 mole of blank, is due to the amount of aspirin that actually reacted with the what? Sodium hydroxide. Do you understand it? So, if, let's say, the amount of aspirin that reacted with sodium hydroxide is like, let's say, 2 mole, it means the amount of sodium hydroxide that will be remaining here out of the 10 moles will be how many moles? 8 moles. It means HCl here, how many moles of HCl will react? 8 mole. Are you getting it now? So your value in that case will be the 10 mole minus what? 8 mole, which will give us how many moles? 2 moles. This 2 mole now will be the amount that reacted due to the presence of what? Aspirin. Do you get it now? So that's how the practical is actually carried out. But then we use titer volume. Now, how is the title volume used? Using the same illustration, you are going to have two setup. You have the first setup where you have the blank. You have the blank, which is something like this. And then you have the second setup where you have this one here is like your, this one here is your blank. What did we say is present in the blank? You are titrating ACl with sodium hydroxide. It means the blank contains only what? Sodium hydroxide. Why? The main experiment will contain aspirin plus what? Sodium what? Hydroxide. True or false? Now, any title value you have here, let's say title value is what? 10 mil. And then let's say this title value here is what? 15 mil. Like I told you, this one must always be higher than this. Now, note that the blank contain only what? Sodium hydroxide. True or false? Plus, now, if you use sodium hydroxide minus, let's say, aspirin plus sodium hydroxide will give us what? Now, sodium hydroxide, what was the amount of mil that you have here? 15 mil. True or false? Now, minus aspirin plus sodium hydroxide, what was the amount you have here? 10 mil. Are you getting it now? If you subtract 15 mil minus 10 mil, what is that going to give to us? 5 mil. Now, what do you think this 5 mil represent? The 5 mil is the volume that reacted with what? Aspirin. Are you getting it now? The 5 mil is the volume that reacted with what? Aspirin. Do you know why? Because if you look at this very well, if you use this minus to put through the bracket like normal mathematics, this will be what? Sodium hydroxide minus what? Aspirin minus what? Sodium hydroxide. Sodium hydroxide will cancel what? Sodium hydroxide. So what is left is what? Aspirin. So we say that this 5 mil is due to the presence of what? Aspirin. Do you understand? So the 5 mil is what is due to the presence of aspirin. So for back titration, first of all, you have a blank. The blank means you titrate the acid given to you with the given base without addition of what you are assaying. Are you getting it? Why the second one means you titrate the acid with what? What you are assaying in this place is what? Aspirin plus what? The base. The titer value here for the blank must always be higher than the titer value for the acid, for the main experiment, which contains aspirin. In such a way, now when you subtract the two titer value, it will give you the titer value due to the what? Aspirin, which is the titer value of the what? Aspirin. Is that okay? Now, that is that. So we have a particular practical question under this. Let's quickly run through this. The question says, okay. The question is very easy. Say weigh 0.3 gram. Now, weigh 0.3 gram of acetylsalicylic acid into a conical flask and add 25 ml of 0.1 molar sodium hydroxide. This is acetylsalicylic acid plus 0.1 molar, 25 ml of 0.1 molar sodium hydroxide. This one now is the main experiment, the one that contains the aspirin now. Acetylsalicylic acid is the aspirin. So this preparation is for the main what? Experiment. Are you getting it now? Immerse the conical flask into a water bath for 10 minutes. Cool under running water. Then titrate the excess sodium hydroxide. Now when we talk about excess sodium hydroxide, we don't mean you will see something that is flowing in one corner that you now call excess. No. It's still the same solution, but it contains some amount of sodium hydroxide that have not what? Reacted. Are you getting it? With 0.1 molar HCl using 5 drops of phenol red as indicator. Are you getting it now? Then repeat the experiment. Carry out 2 blind determination by titrating 0.1 molar HCl against 25 ml of 0.1 molar sodium hydroxide. So this one now is the blank. Now you see that in the blank, you don't have the aspirin. You only have HCl and what? Sodium hydroxide. Why the main experiment, you have 0.3 gram of acetylsalicylic acid in a conical flask, add 25 ml of 0.1 molar sodium hydroxide, immerse the conical flask into a water bath for 10 minutes, cool under running water, then titrate the excess sodium hydroxide with 0.1 molar HCl using 5 drops of water. So you are going to have two titration, the one for the blank and the one for what? This one. Now, the titer values we have are this. That of the blank is 49.5. Is that okay? And then that for the back titration is what? 36.1. When we talk about the back titration, is the one that contains the main ingredient you are titrating for. Do you understand? Two titration. The first one was the one that contains acetylsalicylic acid. We put it in sodium hydroxide. So we have acetylsalicylic acid, which is aspirin, plus what? Sodium hydroxide. Titrate that one. Then we now have 0.1 molar HCl with 0.1 molar sodium hydroxide. Titrate them. This one now is your blank. No aspirin. This one now is what? For the back titration that contains what? Aspirin. Now, what do you do to get the titer value due to the presence of aspirin? What did we say we are going to do? To get the titer value due to the presence of aspirin, what do you say we are going to do? We say we subtract the titer value from this minus this, abi? To get the one due to what? Aspirin. True or false? So titer value due to aspirin will be equals to 49.5 minus 36.1. What did that give to you? That will give us 13.4. Abi? 13.4 centimeter cube. So these are titer value. Is that okay? The titer value due to aspirin. Are you getting it now? That is what you are concerned about. That means this is the amount of sodium hydroxide that actually reacted with what? Aspirin. Is that okay? This is the amount of sodium hydroxide that reacted with what? Aspirin. Because now that sodium hydroxide, when react with aspirin, now actually make aspirin to reduce the molar concentration of what? Sodium hydroxide. In such a way that when that sodium hydroxide was titrated with HCl, it reduced the titer value to what? 36.1. Do you understand the concept? Look at it. Let me explain again. Sodium hydroxide had reacted with aspirin. It means if 10 moles of aspirin was there before, or let's say if, let me use the values you have here. Let me now use more. If 49.5 centimeter cube of sodium hydroxide is what is supposed to react with the HCl, due to the presence of aspirin, the aspirin don't remove some percentage, which is 13.4. Are you getting it? The amount that will now react with the HCl will now be what? 36.1. Because aspirin don't neutralize some of the sodium hydroxide. So this is the sodium hydroxide without what? Aspirin. Reacting with what? HCl. This one now is the sodium hydroxide with what? Aspirin. Are you getting it? But aspirin now already cancel some amount from this 49.5. And that amount when aspirin cancel, now we can subtract to give us 13.4 sodium hydroxide is the amount of sodium hydroxide that reacted with what? Aspirin. Do you get it now? So now we are now coming to do our calculation. So we have our titer value for aspirin is what? 13.4 centimeter cube AB. So we are going to come here and start our calculation. Now the reaction is between sodium hydroxide and aspirin. So we have titer value. You come here, write it at the corner. What did you get? 13.4 Abi? Centimeter cube. Abi? Now, let's write the equation of reaction. You have acetylsalicylic what? Acid, which is something like this. Abi? Then OOH. Plus, it always reacts with 2 mole of what? Sodium hydroxide. To give what? To give this product. The product is going to give something like this. Right? We're going to have something like this. COO. Or firstly, it's going to give us OH. And there will be COO. Na plus what? CH3 COO Na plus what? 2H2O. Now you must memorize this equation of reaction. It's very, very important. Sometimes they may give you the milli equivalent, they may not give it to you. So you must memorize this, which is what is on the board. Now, if you calculate, the mass of acetylsalicylic acid was already given. If you look at it, acetylsalicylic acid is CH3OCO, this sheet here, which is C9H8O4. C9H8O4. Are you getting it? Now, from the equation of reaction, what do you say this one is? C9H8O4. How many moles of aspirin, which is acetylsalicylic acid, react with 2 moles of sodium hydroxide? 1 mole. Are you getting it now? So you say 1 mole of aspirin reacts with how many moles of sodium hydroxide? 2 mole sodium hydroxide. We want to calculate our milli equivalent. C9H8O4. Carbon is how many? 12. So calculate that. Carbon is 12. Total is what? 180 gram of what? C9H8O4. React with 2 mole of the sodium hydroxide. Now, what did we say concerning this thing? We say a number of mole is usually molarity times what? Volume. Right? Now, so this will give us 2 moles of sodium hydroxide. We want to find the milli equivalent. Now, however, I told you that number of mole is molarity times volume. Since you have 2 mole, you see that the molarity is 2 and the volume is what? 1, or volume is 2 and molarity is what? 1. Now, you are not going to come here. One way to actually determine the one that you are going to use is to come here and see in the question, how many mole of sodium hydroxide did they use? They use 0.1 mole sodium hydroxide. Now, it is easier to get from 1, are you getting it, to 0.1 than what? 2. So, since we use 0.1 mole sodium hydroxide, concentration of sodium hydroxide is what? 0.1 molar. Now, what you are now going to do is say N will be 1 molar times the volume is what? 2 liter. True or false? Because we said, since the number of moles here is 2, you must make sure that everything here is what? 2, because 1 mole times 2 liter is going to give us what? 2. Right? Now, 2 liter is still the same thing as what? 2000 milliliter. True or false? So you are now going to come here and say 1 mole, 2000 what? Milliliter. Right? Now, at the end of the day, to find our milli equivalent, first of all, we have to convert this 1 molar, since we use 0.1 molar sodium hydroxide for our titration. That's why I said, before you get your milli equivalent, go back to the titrant, the concentration of the what? Titrant. That's why we determine what you are going to find for your what? Milli equivalent. So this one will be divided by what? 10. And this will give us 18.0 gram of what? C9H8O4 react to give us what? This divided by this, 0.1 molar, then 2000 milliliter. Right? So divide both sides by what? 2000 to get 1 milliliter, because we are looking for the what? Milli equivalent. So you guys should do that for me and tell me the value you get.
0.009.
0. What?
009.
0.009 gram of C9H8O4 is present in 0.1 molar solution of 1 ml of what? Sodium what?
Hydroxide.
Sodium hydroxide. Now, the interpretation of this is that for 1 ml of 0.1 mole, this is supposed to be 0.1 mole sodium hydroxide, the amount of aspirin that will react is 0.09 gram. Now, how many what is the titer value we had here due to aspirin? 13.4. Centimeter cube is same as mil. So you are now going to come here and use your normal cross multiplying in case. But I'm going to show you the idea of factor and the rest sheet. So you are going to now say this will be equals to 0.009 gram C9H8O4 reacted with how many mil of sodium hydroxide? 1 mil. Abi? Sodium what? Hydroxide. What was the amount due to aspirin? 13.4, right? So it means 13.4 mil of sodium hydroxide will react with how many mil of aspirin? Will react with how many gram of aspirin? X. So at this point in time, you what? Cross multiply. Is that okay? So you have X will be equals to, multiply this and this. What is that going to give to us? 0. What? 1206 gram. That is what is present in what? 13.4 mil of aspirin. Is that okay? That is what is present in what? 13.4 mil of what? Aspirin. Now you are not going to come down. In case you don't want to use this method, you are not going to use the method of what? Calculated weight and milli equivalent sheet. You are not going to say calculated weight is equals to what? Milli equivalent times what? Times titer value times what? Factor. What is the factor in this case? Calculated weight will be equals to, what is the milli equivalent? Milli equivalent is what? 0.009 gram. Titer value is what? 13.4 times the factor. I told you that since you are not standardizing twice, the factor is always what? 1. Or let's say standardized. So what will that give to us? It will give us what? Calculated weight to be what? 0.1206 gram. Is that okay? Now you are now going to come back to this thing and read again. Weigh 0.3 gram of acetyl salicylic acid, which is 0.3 gram of what? Aspirin. True or false? So that's salicylic acid is aspirin. Into a conical flask and add 25 ml of 0.1 molar sodium hydroxide. Immerse the conical flask into a water bath for 10 minutes. Now this was what you actually titrated. What is the amount, the mass you titrated? 0.3 gram was the mass you titrated. You did not take part of it, you titrated the entire thing. So it means the amount you actually titrated, you felt you titrated, the amount you felt is present there is what? 0.3 gram. That was the one you took for your titration. But at the end of the titration, you now discover that the amount that is inside is what? 0.1206. Are you getting it now? So you now have to get your percentage purity. What is the formula for percentage purity? Say percentage purity will be equals to the calculated weight all over what? Expected weight. The expected weight is 0.3 now. That's what we are expecting. But what we got was what? 0.1206. You can use calculated all over actual weight. Calculated weight all over what? Expected weight. Look at it. When 0.3 gram of acetyl salicylic acid into a conical flask and add 25 ml of 0.1 mole sodium hydroxide. Immerse the conical flask into a water bath for 10 minutes. Cool under running water and then titrate the excess sodium hydroxide with 0.1 molar. It means the amount of acetyl salicylic acid they used for the experiment was what? 0.3 gram. You didn't pipette part of it. You used the entire 0.3 gram.
Not like that.
Not like the first one that you have to pipette. Are you getting it now? So at the end of the day, what do you have? What do you think will be your answer? Calculated weight is what? 0. Are you getting it? Expected weight is what? 0.30 times what? 100%. This is times 100% here for the percentage purity. What do you think will be the mass here? Do fast. 40 point what? 40.2%. What is the weight by what? Weight. Are you getting it now? 40.2% weight by weight. So this is the percentage purity for sodium, for acetylsalicylic acid. We are done with this particular practical. So we'll see in the next one.